Okay, good afternoon and welcome to all the attendees to the ELISE Action Webinar number 10, titled Geospatial Data and Artificial Intelligence, a deep dive into GeoAI. My name is Lorena Hernandez and I will be co-host together with Simon Brecker, who will be helping me in the logistics and moderation of the question and answer session. Just a couple of words on me. So I am a project officer at the Joint Research Center of the European Commission, and in particular, I work for the European Location Interoperability Solutions for e-Government Action, also known for its short name, ELISE Action. Yeah, thank you. So very shortly, for the benefit of those who are new to the ELISE Action and particularly to this webinar series, I will say that ELISE Action is one of the 54 actions funded by the ISA Square program. The ISA Square program is the European Interoperability Program, aiming at providing cross-border and cross-sector interoperability solutions for all public administrations, businesses, and citizens. The ELISE action is unique because it is the only action focusing really on location dimension and in particular to location in location interoperability as a driver for enabling the digital transformation. Next slide, please. Thank you. So within the context of the ELISE knowledge transfer activities, we are organizing periodically these webinar series. And the purpose of these events is actually to engage in a quick way, in an agile way, with topics of relevance to the digital transformation by harnessing the use of spatial data and technology. You will find all the information on these webinars, including the supporting slide and recording in the ELISE Join Up page, which is indicated in the bottom of this slide, and that for sure will be shared with you. So the topic that brings us here today is GeoAI. I think we can all agree that the change in data culture is fueling the rapid growth of AI work. And in ELISE, we would like to reflect on the role that Geospatial plays in artificial intelligence, and more specifically, we would like to answer one overarching question for this webinar. The question would be, what is the potential of artificial intelligence for geospatial thinking, and how can geospatial data contribute to the momentum of artificial intelligence? So to walk us through the GeoAI concept and answer our central question, we have today with us Sebastiaan van der Peijl, Dhananjay Ipparthi and Lea Ytrehus from Deloitte Belgium. As you can see, they are experts in both public sector policy and analytics and cognitive robotics and intelligent automation, who together with the team of the ELISE Action at the JRC have carried out the research for this webinar. The colleagues from Deloitte will give a 40-minute presentation, which is divided into 6 different sections, plus a follow-up question and answer session. They will start by setting the scene and explaining some basic key terms for this webinar, such as, of course, what is artificial intelligence and the relationships with other key terms, such as machine learning, deep learning, and of course, geospatial artificial intelligence or GeoAI. Once they find what GeoAI is, they will dive deeper into the concept to show what are the origins, the present, as well as the future trends expected for GeoAI, while highlighting the particularities of this sub-branch of AI. Then, the boost of artificial intelligence and specifically of GeoAI cannot be understood without referring to the converging socio-political and technological context. This will be explained in section 3. In section 4, they will show us how GeoAI is actually applied. And to stay on time, you attendees will be helping us in selecting the domains you'd like to see best, to be showcased. Then in section 5, we will see what are the efforts and challenges in regards to interoperability. And finally, we will conclude by highlighting some key takeaway messages for the webinar. So before starting, very quickly, so the presentation, as I told you, will be of around 40-45 minutes. And then we will start the question and answer session. Please use the chat box window to raise in a question or comment that comes to your mind during the webinar. We will try to address them afterwards. And please, there are foreseen some polls during the presentation to get input from you. If you are users of the Zoom app, be it desktop or mobile, you will be, you'll see prompting questions at different stages of the presentation. So with that, I wish you a pleasant webinar, and without more delay, I hand over to Simon, who will be breaking the ice with some quick polls to understand some details from the audience. Thank you.
Yes, thank you, Lorena, for this nice introduction. So before we are starting with the presentation, since the audience today is quite colorful, we would like to start with some polling. So as you can see, in the next half a minute, please answer to this poll. So what is your affiliation and how familiar are you with the concept of GeoAI? So the poll is supposed to appear in your windows already if you are using the apps. Yes, indeed. So you are voting. Okay, so we'll stop the voting and share the results. So obviously the most of you are coming from the academia and research, then from national public administration, then for regional public administration and private sector large enterprises. And most of you know the basics of the concept of GeoAI. So I think this is a good input for our speakers. So and at this point, I'll give the floor to Sebastiaan. Please, Sebastiaan.
Yes, thank you, Simon and Lorena, for the introductions. And hello and welcome everyone, also on my behalf. Thank you for joining us on this interesting topic of GeoAI. I will take you quickly through the introduction, setting the scene and some key terms. As most of you know the basics, I think these terms will be somewhat familiar to you. And then I will give the word to my colleagues to go into the intro. What we're starting with here is a quote from the recent Commission white paper on artificial intelligence that sets out AI as a fast developing driver for change in many different domains. Here are some mentioned: healthcare, farming, climate change, production systems, manufacturing, security, and many, many others. And we've also looked at many of these applications for the webinar we have today, and we will touch upon these later. So if you go to the next slide, we're looking more at here, what is AI and what is the potential for geospatial thinking? So our own Deloitte AI lab defines AI as the field of computing where intelligent machines augment human cognitive capabilities and experiences. And so the main question here is, what potential does that have for geospatial? And if you look at the equation on the middle of the slide here, combining the increased availability of geospatial data, the advancements in the field of artificial intelligence, and the availability of massive computing power, that is what creates the momentum to contribute to the mounting relevance of the potential of GeoAI. So AI with geospatial thinking as a subfield of spatial data science can create not only more intelligent geographical information, but also new methods, systems, and services in the public and private sector. And this momentum also enables to maximize the use of geolocated data, implementation of geospatial analytics, and development of location-based services. Next slide. For this webinar, we'll use the definition of AI that was also provided by the EU high-level expert group on AI. So artificial intelligence as systems, software, and possibly hardware designed by humans that, if given a complex goal, act in the physical or digital dimension by perceiving their environment through data acquisition, interpreting the collected structured or unstructured data, reasoning on the knowledge or processing of the information derived from that data, and deciding the best actions to take to achieve the given goal. AI systems can either use symbolic rules or learn a numeric model, and they can also adapt their behavior by analyzing how the environment is affected by their previous action. So if we go to the next slide, if we look at the relationships between the different elements here, so artificial intelligence and geospatial, the UN DGIM defines GeoAI as a sub-discipline of artificial intelligence using machine learning to extract knowledge from spatial data. That's what you see on the right hand of the slide. And that builds on the capabilities in the field of artificial intelligence, particularly machine learning, For example, neural networks and deep learning is part of that. Next slide. So building on these, the definition of GeoAI used in the context of this webinar is on the slide here. So geospatial artificial intelligence is an emerging scientific discipline that combines innovations in spatial science, artificial intelligence methods in machine learning, for example, deep learning, data mining, and high performance computing to extract knowledge from spatial big data. And that's also quoted from the researchers that you see listed there below. So this definition puts AI and geospatial thinking hand in hand, as what we're trying to show with the trilogy picture there, not just supporting AI for geospatial information systems or the other way around, but more like an integrated system. So these terms set a bit the scene for what it is that we're talking about today and how we see these relations. And now I hand over to Dhananjay to take us through GeoAI trends and research areas.
Hello, I hope you guys can hear me clearly. Essentially in this section, what we'll be doing is we'll be touching upon the origins of GeoAI. And then we'll be sort of walking you through what's being done, what's the state of the art, and what we believe is the future outlook of the space. So GeoAI is not something that's new, right? It has been around for a while. And I think the first mention of this as a concept was in the late 80s in the context, I think it was a paper by NASA that had put out some literature as to how imaging can be used in the context of, images can be used in the context of locating certain elements that they are interested in, some subjects of interest. But I think in the mid-90s with the work of Black, what happened was he used neural networks, which is essentially a machine learning technique, in order to untangle the fully constrained gravity model. And the idea is that if you were able to untangle the gravity model, the fully constrained gravity model, then you could apply the same sort of principles in understanding and unlocking the potential that lies within spatial understanding, so geospatial information, right? So based on this, this basis, geospatial AI, so GeoAI has sort of evolved into a few more aspects, right? So which we can see in the next slide, and has therefore sort of become an entity is self-standing, that now has its own force and its own momentum, as Sebastiaan was alluding to in the previous slides. And essentially, the fact is that GeoAI is, as Seb mentioned, the confluence of geospatial thinking and artificial intelligence, right? So as you would understand, there is there's an inherent desire for humans to understand what's around us, what exists in our surroundings. And essentially, we are also curious to the point where we use current techniques in order to understand natural phenomena. And that's where the confluence of the information that's there in nature, as well as the advancement in artificial intelligence, have given rise to some interesting sort of applications. For instance, real-time crop yields, vehicle routing, which I suppose we use on a regular basis, marine biome mapping, gravity anomalies, and the likes of it. As you can see, these spread beyond the context. If you could please go back. These spread beyond the context of machine learning to the extent of supervised learning, unsupervised reinforcement learnings, etc. And the uniqueness of GeoAI is its ability to handle both temporal and spatial features. And in that, it is a very unique sort of a domain which uses both of these aspects in order to come up with interesting insights, which then we can use to our advantage. Now, where are we going with all this information? So as we know that we are on the rise in terms of increasing our skills and technical ability within the domains of artificial intelligence. So given the fact that with AI, we are also evolving, the geospatial domain is also evolving. What we see is this sort of interesting curve where we start off hyper ambitious and we want like edge AI, auto ML, general intelligence and such, but then we sort of get a little realistic through in the trough of disillusionment, and eventually you have a plateau of productivity. And I think that currently we are probably in the trough of disillusionment, but I think it's more positive than that, right? So the future outlook would be that we look at what the advancements are in terms of algorithmics, in terms of machine learning, and we use that with the wealth of data that's out there in order to make interesting applications and gain insights into what we have. So with that in view, we will then look at the confluence of the political sort of aspects of these things, and for that I will hand over the stage to Lea.
Hello everyone, thank you very much. I hope you can hear me all right as well. If not, let me know. So as DJ mentioned, in the first part of the section, we will look to briefly sort of provide an overview of European policy and initiatives in the field, and how these initiatives are really aimed at creating an enabling environment for the uptake of AI. So first of all, something that's of course important to mention is the Declaration of Cooperation on AI in 2018, which was really a milestone where the member states agreed to work together on the most important issues raised by AI. So this is everything from ensuring Europe's competitiveness and the research and deployment of AI to dealing with social, economic, ethical, and legal questions as well. And at the same time, the European Commission issued a communication on AI for Europe, which earmarked 1.5 billion euro to support AI research until 2020. And as I'm sure many of you know, Horizon 2020 had already comprised of 2.6 billion euro investment in AI as well. Moreover, the EC white paper on artificial intelligence was also really a key milestone in this creating this enabling environment. And it was a milestone in the sense that it's a coordinated political approach on the implications of AI, and also a reflection on the better use of big data for innovation, which we know is highly important. So interestingly, this white paper promotes and reflects the policy based on two pillars, which is also kind of reflected in our webinar. So it's really about building a European ecosystem of excellence. So this is about, of course, focusing on creating an environment that enables the uptake of AI technology, but also building a European ecosystem of trust. So here we're talking more about the regulatory environment that is necessary to foster this trust. So to this end, the high-level expert group published some guidelines on trustworthy AI in April 2019. And last but not least, of course, we would also like to mention AI Watch, so the Commission's knowledge service to monitor the development, uptake, and impact of AI for Europe. So its objectives are, amongst others, to develop an overview and analysis of the European AI ecosystem, monitor the uptake and progress of AI technology, as well as an AI index, which will include dimensions relevant for policymaking. And lastly, as some of the case examples we'll give you in this presentation will demonstrate, the uptake of GeoAI also touches upon many different policy areas, and of course the successful interoperability between public services. So here we'll just highlight 3 points. So concerning the need for an urban digital ecosystem, or plural digital ecosystems, the realization of policies such as the European Green Deal calls for exactly this, an urban ecosystem that allows created value-added services, but also for simulations of policy choices to decision makers across cities and communities of the EU. And then secondly, and importantly, of course, as well for the ELISE action, is the need for interoperability between systems and services. This remains at the core of the uptake of GeoAI. So worth mentioning here is, of course, the OGC domain working group on GeoAI. This working group has the direct objective to provide an open forum for discussion, presentation of interoperability requirements, and amongst them, also the implementation of OGC standards in this domain. Lastly, of these 3 points is also the need, of course, for coherent and commonly agreed upon standards, where there's certainly many technical committees. We will highlight here ISO, that are working in the field of, amongst others, AI and IoT to achieve real working standards. So in sum, all of these elements will be key in creating an enabling environment in Europe for the uptake of GeoAI. So for the purpose of this webinar, the findings of AI Watch in their newly published report on AI in public services provided also a number of highly interesting insights, we think. So among them, they found that there is indeed a growing use of AI within governments. So this is often to support the redesigning of internal processes, enhance policy-making mechanisms, improving public service delivery, and engaging with citizens. And it was also found that there are certain policy sectors, and naturally so, where AI is more used. So we have general public services at 33% of the cases, and health and economic affairs also listed here. And section 4 of this presentation will provide some case examples from some of these sectors. On that note, we will move to the more technical context. So please, Dhananjay.
Right. So in this part, as again, to touch back on what Sebastiaan was telling, there are 3 essential forces that govern the momentum of GeoAI, and that is big data and analytics, massive computing power, and human system interaction. Now, GeoAI's lifeblood comes from its data. So let's look at what is big data and analytics. So big data is essentially data that is voluminous, as the name suggests, that comes in high velocities. Think about streaming data of Twitter streams, etc. So it's a massive velocity of data. And think about data that's highly variable, right? So now you have data that is in different forms, different formats. So this in collection is what is big data. What is this data useful for? It's useful for advanced predictions, pattern recognitions, classifications, and something that's very current today for those of you who use Netflix, Amazon, etc. They're used for personalizations to enhance your customer experience, and also another very cool and very current topic, which is deep learning, which is essentially, as Seb sort of touched upon in his introductory slides, which is a part of machine learning, which uses, again, several more nodes of information and a lot more data in that regard for its learning. What is the future outlook? So I think the future outlook is bright, right? And why do I say this is because, as you know, we are now collecting data from a plethora of systems, right? You now have IoT systems which are taking in information from machines, something that in the past was not thought of. As you can understand, we are getting more connected, so more systems are connected. And if for those of you who live in smart homes, you would have an appreciation of this connection. As I mentioned, with regard to enhanced customer experiences, data is getting more personalized, right? So everybody has their own take and own sort of data to provide. And using all of this, what happens is that you have the potential of having far more accurate predictions and data and information that's coming at much higher velocities, and you have the infrastructure to support this sort of uptake. But while all of this is rosy, I think there is a very important need to ensure quality, privacy, security, trust, and the critical aspect of prevention of discrimination and bias. What does all of this mean for GeoAI? It means that we are now going to be exposed to advanced forms of gathering data, a far more efficient way of making data flow from one system to the other, the ability to store gigantic volumes of data, and eventually to have the potential of providing our systems with much better insights and predictions which reduce the reality gap. Now, in order to be able to use all this data, you have to have the corresponding computing power. And that comes to the massive computing power that we talk about with regard to GeoAI. And let's start with the basics, right? So what is computing power? Computing power is generally a function of three parameters: speed, volume, and type of computations. And the way to, and a simple analogy for this is your laptop, right? Or your personal computing machine, which essentially there is a particular speed at which the processor runs, 3.6, 2.8, whatever. You have volumes. Think 10 years ago or 15 years ago, you were hard pressed to have even a gigabyte's worth of information. Now you have terabytes that you can store on your computers. And the different types of computations that we are talking about relate to the different nodes and the different volumes of, or different aspects and different types of data that are now being ingested in a more heterogeneous form in order to be able to provide insights. Why is all this important? It's because to solve complex problems, problems with several interconnected nodes, you would need this ability to compute. And in order to do that, you would need the corresponding computing power. As those of you who are aware, we are already in the process of moving most of our computation to the cloud. And then from there, we are now sort of even evolving to computing farms. For those who are aware, there's also field programmable gate arrays that are being used, GPUs that are used extensively in video gaming consoles, and eventually, I think the very cool frontier that is in quantum computing. So that's sort of like where we are looking at and what the future outlook is of computing power. And what does all of this mean to GeoAI is essentially deeper insights, faster insights, and the ability to manage complex geospatial analysis. Now, in order to interact with these sorts of systems, you have humans. You have particular systems called human system integration, right? So HSI systems, which is essentially the expertise that pertains to how humans interact with AI systems. Let's start with like the absolute basics of this is actually how you use apps on your phone. So the fact that you type certain information, you swipe, you pinch, to zoom out, and you sort of spread your fingers to zoom into things. All of this is how we as humans are interacting with artificial intelligence systems. What can this be extended to? Many things, right? So for example, on one extreme, you have the ability to guide swarms of robots using gestures. So here you're using simple gestures to interact with swarms of robots. And also the aspect of using virtual, augmented, and mixed realities, right? Which is also now becoming more and more prevalent, mostly in terms of entertainment, but slowly sort of creeping into research domains as well. So in this regard, it's also worthwhile to mention that chatbots are also an aspect of how we interact with artificial intelligence systems. And there was a very interesting study that was performed in the administrations of Latvia and the cities of Vienna and Bern, which indicated how people were able to interact using chatbots with artificial intelligence systems. What does the future hold for us in this respect? Our realities could be enhanced or augmented with virtual, augmented, or mixed reality aspects. Our worlds could become more personalized. So just as one person's cell phone is markedly different from another person's in terms of how you arrange icons and where you store files and etc., etc. So in the same way, our virtual worlds will become much more personalized. And then the third one, which I think is of particular interest in this context, is public services that are flexible in time and space. So currently, if one were to imagine that you have to go to the commune to fill up certain forms, you can do so only between 8 and 12, which means that your children have to be taken care of by somebody else to drop them off at school, and your work hours, etc., etc. It's quite complex. So perhaps going forward, what would happen is that we would be able to use public services at our leisure. So in bed at 9 p.m., you're able to use these public services. And this is what what also plays into the fact that we are able to use human system interactions in order to carve out how we as humans are interacting with artificial intelligence systems. Now, what does this mean for GeoAI is new and improved ways to interact with artificial intelligence systems, obviously, but also into how we gain insight from geospatial systems. So if one were to imagine that you want to start doing some research in a volcano, now you could recreate this volcano's innards using information that you've gathered, that you can now immerse yourself into this sort of environment without harming yourself, of course, and use tools like robotic systems once again to interact with unfavorable environments. And this in some sort of addresses how GeoAI can benefit from big data, massive computing power, and HSI systems, which are much more advanced and going into and exploring new domains. And with this sort of basis, I think it's now time to sort of take a poll from you as to how we will be, as to what use cases you would like to see. So I hand over the baton to Simon.
Simon?
Perhaps you're on mute.
Sorry for that. Yes, thank you. So so far we've been through key definitions, basic concepts, political context, and the technical environments. It's now time to get into the real cases, to the real world. So there are many of them in the presentations. However, we won't be able to present in detail all of them. So we'll launch a polling for choose from you from the set of next use cases. So geo-enabled mapping, geo-enabled pollution tracking, mHealth applications and public health observatory, GeoAI for optimized freight transportation, satellite data and tracking fields, optimizing sugar beet production and predictive policing. So please choose up to 2 topics. I give you another 15-20 seconds and we'll choose 3 most voted of them that our presenters for Deloitte will go into details. So another 10 seconds, please vote. So we'll finish with voting, sharing the results. So obviously the top score is a GeoAI enabled mapping with 60%. Next one or next 2 are GeoAI enabled pollution tracking and mHealth applications and public health observatory, both with 32%. So please, Leah, Sebastiaan, and Dhananjay, continue.
Thank you very much, Simon. So for the purpose of time, we'll dive right into it. So this is the first case study that you were interested in. So here we're sort of looking at using GeoAI to close the map gap. So this initiative is by Facebook in cooperation with the OpenStreetMap, their initiative Map with AI and Rapid. So why this project? Why highlight it? So it was, as I said, initiated by Facebook Artificial Intelligence, and it was started to tackle 2 challenges specifically. So the first one was the fact that creating accurate maps, despite really significant advancements in data availability, satellite imagery, and software, still today remains a burdensome and time-consuming task. Second reason is also that large parts of the world, as we know, remains unmapped still today. So this is both a development and a security challenge, and Facebook also highlights in this initiative their commitment to support the humanitarian OpenStreetMap team in their efforts to assist relief work through this project. So what is it really that we're talking about here? So this system designed by Facebook provides a new set of specialized map editing tools and services and an interface which is called Rapid. And this has been designed for mapping experts to also be able to review, adjust, and verify the maps, and hence they're in this way sort of maintaining a human dimension for quality review as well. So just to give you an example, this model was used to map more than 300,000 miles of unmapped roads in Thailand at the course of 18 months, and this was a part of an OSM initiative to create freely available maps. So Facebook estimated that it took less than half the time it would have taken if they had used a team of 100 mapping experts. So that's just to show you a little bit the impact something like the system can have. So in terms of geospatial data, right? So Map with AI works in cooperation with OpenStreetMap to make their outputs and databases completely compatible with geospatial databases, and hence is also adding to this strategic objective of ensuring free availability. When we're talking about AI, so in extracting roads from satellite imagery, Map with AI use fully convolutional neural networks for semantic segmentation. So this is in conjunction with large-scale weakly supervised learning. So as the image on this slide shows, on the left, you can see the results of the segmentation model per pixel prediction. So the bright magenta color means higher probability of the pixel belonging to a road. Whilst on the right, you can see a conflation of the vectorized road data with the existing OSM road. So overall, we think that this example shows how GeoAI solutions can impact the efficiency of mapping production, and hence also the ability to provide maps of previously unmapped areas, and of course in this sense support development infrastructure, as well as even humanitarian relief work. So we will move to the next one. Here we would like to highlight GeoAI in health and environment. So this case study is about tackling pollution with AI-enabled tracking. So why do this in the first place, you may ask? So air pollution, as we know, is considered one of the largest environmental health threats of our time. It's currently leading to about 400,000 premature deaths in the EU every year. This is an estimate from the European Environmental Agency's air quality report from 2017. And what is the solution that we're showing you today, or part of a solution, to be a bit more humble? Well, Breeze Technologies, it's a German IT company that was named one of the EU's most promising startups by the European Parliament in 2018. And they also took part in the Copernicus Accelerator program at this time. So this company aims at helping cities and corporations design more efficient clean action plans with artificial intelligence, the Internet of Things, and Earth observation data. So how do they do this? Let's state it in two steps, essentially. First, they developed small-scale air quality sensors that measure common pollutants. So we're talking carbon, nitrogen oxides, ozone, particulate matter, and many more. There's a long list you can see on the website. And then by gathering and combining real-time data from sensors and external data sources such as satellites, their environmental analytics cloud platform uses machine learning and big data technologies to increase data reliability and accuracy. So in sum, these insights can allow for facility management, environmental scientists, and local governments to really understand air quality, what influences it, and how to improve it, of course. So sort of to recap, the geospatial element here is, of course, that the company gathers location and Earth observation data through sensors and satellites to map pollution in urban environments. And on the AI side, as mentioned, they use parameter estimation approaches to really accurately provide measurements based on sensed data. So the air quality sensor produced by the company is said to be intelligent. It's said to be able to recalibrate itself based on what it's learning. And based on this, it can also predict necessary maintenance. So overall, we think that this example really nicely ties together how location data and AI-powered solutions can help tackle pollution by providing new insights to a range of stakeholders, really. We will move straight to the third case study. I believe this was the third one that you wanted to hear about today. So again, it's another case study in the field of public health and environment, and it's the Pulse project, and its mobile health application here. So why we're showcasing this example is really that, in a sense, as more and more data becomes available, we currently have more knowledge on causes and triggers for diseases than ever before. So we can start to imagine really a public health care system that moves from reactive to predictive, and how that could really save both lives and significant public expenditure. And then you may ask, how can GeoAI contribute to this? More specifically, how can GeoAI provide the necessary insights for decision makers to move in this direction? So this project is really interesting in that sense. So what is it all about? Pulse stands for Participatory Urban Living for Sustainable Environments. So it's a Horizon 2020 project with really tangible results. It's a consortium of 13 partners, private to public, small to large. And the project collaborated with 7 smart cities in response to the EU urban agenda and current drivers of public health risks. So this project created the mobile health app Pulsair, as well as a public health observatory, that also has a visual dashboard for policymakers. So to dive really right into the geospatial elements here, this app, Pulsair, is connected to personal tracking devices to map where citizens move in the urban environment. Moreover, citizens can provide their subjective data, so of course physiological and activity data, but also localization data coupled with this. So the application will then show the exposure that each citizen has to air pollutants by combining location information and data from sensors. And the visual dashboard for the Public Health Observatory employs web GIS for spatial analytics. So just to recap the AI elements here, we see that regarding artificial intelligence, this app takes data input and provides information about the health risk. So in this case, it's actually asthma and type 2 diabetes to the users, and suggests specific behavioral modifications to each individual that's delivered through a specific logic of supportive feedback. And secondly, this data is also presented, as I mentioned, in a visual dashboard available to public health decision makers. So this dashboard uses GeoAI by providing exploratory analytical tools complemented by WebGIS. And this combined is a tool that enables spatial analytics. So this is really meant to support public health officials in the design of health promotion interventions, and can even suggest certain interventions at certain times. So in sum, this project uses analytical tools and location data to formulate really tailored policy interventions at both individual and larger societal level. It's powered by data mining, simulations, leveraging spatial, temporal, geolocated data, and knowledge-driven analysis. So we hope that this gave you some insight, some specific applications. As you see here, we have quite a few examples that will be available to you shortly after this webinar. So on that note, we will discuss interoperability efforts and challenges.
Okay, before going into the next section, so now having acquired, let's say, some additional knowledge on GeoAI, nevertheless, there were quite many examples are listed in the presentations, which you will receive after the this webinar. So from your own experience, do any other examples come to your mind? So please vote so in next 10-15 seconds. In case you have some new examples, would you mind to maybe post your examples in the chat box, so we can maybe later share it with the audience? So another 5 seconds. Thank you very much. So mostly you don't have any new, let's say, examples, but there were 7 answers having new examples. So please just put these examples in the chat box. So thank you very much for polling. So since ELISE is about interoperability, actually location interoperability, one of the sections of this webinar is dedicated also to that questions and challenges. So please continue.
Yes, I will take the first slide on that, and I'll try to be very quick given the time. As already explained by Lea, enabling all these different kinds of applications of GeoAI requires tackling interoperability challenges, and there are efforts to address. Whereas UN GGIM mentions clearly that quality assurance and standards are still in their infancy, there are efforts that are picking up to work on standardization as machine learning for geospatial is being adopted more and more by public and private parties. The standards are key to enable interoperability in support of such a mass deployment and adoption of AI in this field. And this is key for enhancing also, as mentioned earlier, the trustworthiness of AI as it becomes more widespread, as well as standardization of algorithms, computational techniques, which allows a higher level of adoption in general. And so bodies and institutions are working to address these standardization issues, such as ISO, for example, who has 2 technical committees working on standards related to GeoAI, like the Committee on AI that has published 5 standards and is working on 14 in addition, among them on trustworthiness of AI, for example. As well as a technical committee on IoT and related technologies, which has published already 26 standards, and there are 7 under development. Among them, a framework for interoperability by IoT systems, for example. There's also the OGC working group on GeoAI that aims to provide an open forum for discussion and presenting interoperability requirements, use cases, pilots, and implementation of the OGC standards in this domain. So that's also very important work. And then there are also national standardization bodies that are working on this, as well as the development of industry and open standards or specifications, such as the Kronos Group, for example, focusing on standards for AI and virtual and augmented reality, as well as frameworks for machine learning interoperability, which we'll go in a bit more depth on in the next slide. There's also the join up page on the rolling plan for ICT standardization that also provides information on standardization activities on AI there. So that's a very interesting resource. Dhananjay?
Yes. So as Seb mentioned, there are several motivations essentially to be able to exchange models and to exchange information between these different AI endeavors that we are undertaking. And in order to do that, in order to leverage from each other's findings, essentially, it would be beneficial to have a framework or a standard in this regard. And so I think the first thing that we need to do is that we need to understand that AI systems are becoming more complex, and as you become more complex, and if you add the added element of you working in a modular fashion, then you essentially are not leveraging from each other's findings. So it's always beneficial to sort of be able to interoperate and to use this information in a more collective manner. And in this, you have the opportunity, which then allows one to use these models seamlessly between different applications. So essentially what's being sort of addressed over here is that you have a disjointed system, which you then sort of join by creating the necessary frameworks and or standards. And in this regard, there are frameworks such as those provided by Onyx, NNEF, EMML, etc., which provide that sort of basis. And then there's also the aspect of being able to explain AI, so interpretability and transparency. So this is a domain where there are tools such as Opera, which essentially are used to understand why a certain AI model was made a certain recommendation. So what is the basis of the classification and such. What is the challenge with regard to GeoAI? Essentially to be able to use these different aspects of different models, and then to address what is critical to all things GeoAI, which is the spatial and temporal aspects, right? So to remove that bias, which could creep in, that is an aspect that should be addressed, and in order for GeoAI's potential to be maximized. So given all of this information, I think that there are a few key takeaways and messages that we shall try to sort of go over really quickly in order to sort of bring this a webinar to a close. The first is that there are opportunities galore, right? So what's happening right now is that you're getting newer, deeper, and more voluminous information, more data, which is only going to continually increase. So that is already a good sign, because more data, more insights. There is a study by Wire which suggests that geospatial AI's market is going to grow by 23% CAGR till in 2023, by 2023. There is a push from within Europe in order to embrace digital technologies like IoT, etc., and bring it into their economy. And then if that was all not enough, I think it's also very noteworthy to see the remarkable and disruptive technologies that the GeoAI community has come up with. And I think those are in itself great motivators for us to sort of continue working in this domain. While there are opportunities, there are also some problems that need to be addressed, or some challenges that need to be addressed. As mentioned, there is a current effort into creating interoperable systems, and I think that there has to be further efforts into standardizing this. Standardizing it in this regard would make sure that the quality is maintained, that we're able to regulate these services, which are very often related to the public sector. And very importantly, that we do not have discrimination and bias with such systems. All of this can be addressed through well thought out and well formulated standards. And then we will have to have regulations in this respect to make sure that our data is protected, people are liable for what they do, and once again, that we avoid discrimination. And finally, as mentioned earlier, that we have to make sure that we are able to trust these machines, that we're able to understand why they are saying the things they do. And in order to do that, making AI more explainable is critically important. Now, before you head out and you have your coffees or whatever, I think there are a few things that we would like to make sure that you take away, and these are the key messages. And these are essentially still just a roundup of what we've been discussing thus far, which is that there is more data out there. AI in itself is advancing. The computing power is increasing, all of which are critical for the momentum of GeoAI. Then AI presents new opportunities to integrate, exploit, and make use of these geospatial data and the insights that we're getting from there. And then we can use these insights in order to further public sector capabilities, from moving to the reactive to predictive, and hopefully eventually the prescriptive sort of aspects of AI. And finally, that AI should and could be used for the increase in growth, efficiency, security of our citizens at large. So in that, I will hand this back over to Simon. Thank you very much.
Yes, thank you very much. In the meantime, we started the next polling about the challenges. Do you see for the uptake of AI for geospatial? Some of you already noticed that the polling is running. So please vote, answer the question here. So which of the, let's say, challenges you see? So interoperability for public services, common standards, regulation issues of data protections, privacy, liability, the human dimension of trust, and other. So you have some other things that you think that may be challenges. Please specify as well into the chat box. So let's have another 10 seconds for voting. Okay, so let's share the results. So what is quite obvious is that regulation issues were 53% of you thought that it's the biggest challenge. The next one would be interoperability for public services. Then the human dimension of trust and common standards. So, okay, so we actually with this are at the end of the content of the webinar. So before we continue, I would like to run another poll with a question: how would you rate this webinar? Were you satisfied, more than satisfied, very satisfied, partially, not at all satisfied? So what would be your, let's say, judgment of this webinar today? So let's have another 5 seconds for voting. Thank you very much. So here are the results. So mostly you were satisfied, some of them also partially satisfied, some of them not at all. But in general, I think our score is above average with the results. So thank you very much. I'll give floor back to Lorena to, let's say, announce some of our next webinars.
Yes, thank you, Simon. Sorry, I was thinking that this slide would come later on, but yes, as you can see in the image, after this webinar, we will take also the summer break, and the next topics that we will be exploring will be smart cities, emerging technologies in general, and we will also look at geospatial enabled public services, or also what they call location-aware public services. Because this is what you choose in the last webinar. You were mostly interested in this topic, so we'll try to yes, to go through them. And now maybe Simon, I don't know if we should start the Q&A session.
Yes, I think it would be the right time to continue with that. We are a bit late. We started a bit late, but I think it was a quite interesting topic anyhow. I've just observed that we have an honor that also the chair of the working group at OGC on GeoAI is with us. So maybe before we turn to the questions, if there are some comments from you, since we are very much interested in the interoperabilities, challenges and issues. So please, Kim, would you make some comments maybe? Can you hear us, Kim? She doesn't hear us. Okay, then maybe answer for the first. There was a question about. Sorry to. Let me check into the chat box. First question was by Virginia Martinez. Previously, you explained the policy about artificial intelligence in European Union, but how do you combine this policy with the geographical data, perhaps through Inspire protocol? Maybe, I don't know, Lorena, would you answer that question?
Yes. Yes, thank you, Virginia, for this question. So first of all, I'm not an expert in artificial intelligence, but at least coming from the geospatial domain, I see that, okay, data in general, and in particular geospatial data, I think they can play an important role in providing training data set, I mean, input data for artificial intelligence, because, I mean, we agree that geospatial data also, I mean, what it makes it different is that they contain rich spatiotemporal features that allow to uncover, I mean, to have better insights on spatial relations that are not necessarily evident. And in particular, since you were mentioning INSPIRE, I personally think that there is plenty of potential in INSPIRE harmonized data when providing high quality training data for EU-wide projects in this case, because INSPIRE is a directive that is covering the whole Europe and also some EFTA countries. And because I mean, they were designed, I mean, INSPIRE data was designed to be delivering interoperable and consistent attributes data. So I think, yes, I think they play a big role in artificial intelligence, maybe in classification. Yeah. I don't know if someone wants maybe to amend or to elaborate more on my.
Sebastiaan, maybe some comments, additional comments on that?
Yeah, maybe very quickly, EU policy or policy in this domain is of course a rather wide topic, but we're talking about INSPIRE. I mean, INSPIRE is more about static data. So AI is as we've had in the webinar, also more about integrating dynamic data, combining, you know, INSPIRE type of data with sensors and other data that is volume has a high velocity. I think that's key. So GeoAI is in that sense influencing how we deal with the data that exists and new types of data coming in, that new kinds of algorithms that we can use to analyze the data.
Okay, thank you very much. So in the meantime, we realized that Kim from OGC is without microphone, unfortunately. So maybe we'll discuss next time. So there was another question, I think, from Rizwan Bulbul. Can linked geodata play a role in semantic interoperability for GeoAI? Maybe the question from Dhananjay.
So the question is, can linked geodata play a role in semantic interoperability? Could you tell me, like, Rizwan, what is, unfortunately, I'm not familiar with what is linked geodata. Or Simon, Lorena, if you are familiar, could you just lay the foundation for that? And then I can happily give you my perspective on that.
And maybe Lorena.
I mean, the first thought that comes to my mind, I mean, relates a lot with the answer that I gave earlier. I think that, yes, GeoLink data could have also a big role in training data because, I mean.
What is it fundamentally, if I may ask?
So, I mean, I don't have a definition right now, but the idea is that there are ontologies in the background that are like giving the relationships of what each concept is, and then you can link the different terms together and also data. I mean, it's like putting data on the web through annotated information. Yeah.
Right. So Rizwan, I think in this regard, right, so if you're talking about the semantic web and then the web ontology language, etc., of course, right? So you are creating a sort of level playing field with which you can sort of exchange data in a more, let's say, systematic way. And of course, there's without a doubt that I think that having linked geodata would definitely will definitely assist in the interoperability of GeoAI, without a doubt. And in that, I think the only, let's say, downside is the adoption of these standards, right? And to essentially, how do you enforce these things? So that's one aspect of it. And because to come up with these standards often is not such a straightforward way that, you know, suits everybody's system. So that's something that I believe would potentially provide a sort of hurdle. But apart from that, the potential is definitely there that it will help. Yes.
So maybe some additional comments from Danny here, Danny van der Broeke from KU Leuven. Danny?
Yeah, maybe in addition to what has been said until now, it's worthwhile to mention that in the domain working group that was mentioned of the OGC on GeoAI, this issue was already tackled in some of the meetings with some particular presentations. But more in general, not specifically linked, that is more a technology and a way of storing and handling the data. But of course, semantic web is a lot richer with the ontologies, etc., that were already mentioned. But I think what is important is the way we will, in fact, exchange or interact as a user and as an analyst with our huge data sets, and the way we request or handle the data or question the data to find answers. I think there semantic web might play a very important role. Also in the way we query the data, not in a traditional way, but their semantic web and linked data technology can help tremendously, because it's much closer to how we reason as a human being rather than as a machine. But then we have this interaction with the machine that will help us to get the insight out of this huge amount of data with artificial intelligence. But it's important that this topic is explicitly on the agenda to see and to check how semantic standards can help to facilitate this.
Indeed. Thank you very much, Danny, for this additional comments on that. So before there are no other questions, before we finish, maybe I can also see here is also Jiří Hradec from GRC. He's also doing some work on AI and related with the interesting topic of COVID. So maybe Jiří, can you elaborate maybe in a few sentences what you are doing as well at GRC on that topic?
Yeah, hello all. Can you hear me?
Yes.
Yeah, excellent. I work in the same unit as colleagues who prepared this seminar, and I work on let's say more moonshot projects. At the moment, the most important part of my work is building synthetic populations, because our biggest disadvantage when trying to understand how policies are being implemented, how policies are being designed, are that we work on over-aggregated data. So how to resolve the clash between the need for privacy and the two generic data. This is how we approach it. And when the COVID crisis started, we were approached by the COVID task force. And what we do is COVID contact simulator, where we take the synthetic population down to, let's say, individual level. Then we build a graph, people living in households being part of real houses. And this way we know mobility of people, and we are able to bring in, let's say, behavioral profiles. The nice part on this is all what we can call artificial intelligence. Of course, AI doesn't exist. This is just a bunch of machine learning algorithms, from interactive proportional fitting down to reinforced learning. So the beauty of this is that we simply overcome all the privacy issues, because all our data are at one side synthetic, on the other side they are fully they have the same representation, statistical representation, as the original data. So we are able to use probabilities, and the best of it all is the level of realism that we are able to achieve against ground truth is several orders of magnitude bigger than working on the data aggregates.
Mm-hmm. Okay, thank you very much, Jiří, also for that explanations. So I think we come to the end with the questions. So thank you very much for your questions, also for the comments as well. And giving back floor to Lorena to finish the webinar.
Yes. So again, thank you to all of you for having attended. We finish only with our coordinates. Please join the ELISE community in Join Up to stay tuned to all the events, all the reports, tools that we are producing. You can also follow us on Twitter. There's a functional mailbox if you prefer. And we also have an ELISE playlist in YouTube that, where you can replay all these webinars and other contents. So I hope to see you after the summer break. Ciao.
So have a nice summer break. Bye-bye. Thank you.